Sine of A plus B. Sine A cos B. Plus cos A sine B. Cos of A plus B. Cos A cos B. Minus sine A sine. Now we are deriving, Saurya. Did we start this deriving the formula?
Yes, sir. Kind of a bit.
So multiple and submultiples. Very simple thing is that multiple means you will have 2a, 3a, 4a, and submultiple means you will have a by 2, a by 3, a by 4 like that. So let me give you first of all multiples so that you need not have to separately learn submultiples. You need not have to separately learn submultiples. So let me write that. Number one, in this one, replace B with 2a, B with a. Replace B with a. Then what is that? Sine of A plus a. You have to respond, please. Sine of A plus a is sine 2a. This is sine A, cos A plus cos A, sine A. It is nothing but 2 sine A cos A. Okay. And we can have tan formula also from this one. How do we get the tan formula? That is also important. Simply not by hearting, but if you know how is it derived, that's what I'm saying. The logic what we apply here will be useful even in solving the problems also. I want to make this sine A tan A. That is why I divided with cos A and multiplied with cos A. That becomes cos square A. Then this becomes 2 tan A, and bring that cos square A to the denominator, then thereby it becomes secant square A. Maurya, what is the reciprocal of cos A? Secant A. So that is why it is brought to the denominator. And what is secant square A? Identity, which you have even in your 10th class also.
1 plus tan.
That's it. So what is the other formula for sine 2a? If you want it totally in terms of tan, it is 2 tan A upon 1 plus tan square. Okay, now very, very important formula, what I taught you in the previous class is Cos2a formula. I said I'll be giving 5 stars to this formula. That much important is this, because in calculus also further, it is frequently used. Differential calculus and integral calculus further you'll get. In that one, this Cos2a formula is used. What is the prominence of this formula? That's what I'm saying you now. If you replace B with the A here, if you replace B with the A here, then what happens? You'll be getting cos of A plus A, which is nothing but cos 2a. Then what happens? You'll get cos A into cos A minus sine A into sine A, which is cos square A minus sine square A. That means cos 2a is expressed both in sine and cos. Now, if you want to express only in terms of sine, you will understand. That's why I'm writing this step directly. Instead of cos square A, you can write 1 minus sine square A. Instead of cos square A, you can write 1 minus sine square A. So 1 minus sine square A minus sine square A, which gives you 1 minus 2 sine square A. Not only that, you can even convert it totally to the terms of cos square A. Write this sine square A as 1 minus cos square A. Maurya, are you there?
Yes, sir. Yes, sir.
I'm expressing totally in terms of cos square A. So you write this sine square A as 1 minus cos square A. So 1 minus cos square A, if you simplify now, you'll be getting it as 2 cos square A minus 1. Now, what the method I applied to derive sine 2a in terms of tan, the same is to be applied here also. And it is like this. If you take cos square A minus sine square A, I want to say this in terms of tan, so take cos square A common. If you take cos square A common, what happens? You'll get 1 minus sine square A by cos square A, which is tan square A. Now I'll get this cos square A to the denominator. I'll get this cos square A to the denominator. Cos square A to the denominator gives you secant square A. That secant square A can again be written as 1 plus tan square A. So what is cos 2a purely in terms of tan? What is cos 2a purely in terms of tan is that 1 minus tan square A upon 1 plus tan square. Why am I insisting on this formula? The reason is, I hope you understand that, Maurya, this part. Should I explain?
Yes, sir. Yes, sir. No, sir. No, sir.
Why I'm insisting on this formula is that if you see cos 2a, only cos 2a can be expressed only in terms of sine, only in terms of cos, only in terms of tan. It won't happen with any other formula. That is the prominence of cos 2a formula. Cos 2a can be written both in sine and cos, only in sine, only in cos, only in tan. That's what the importance of this formula. Then what makes it more important, why I gave it 5 stars, I'll explain you. Because if you understand this, instantly you will be getting the idea of applying this formula while working out the problems. Okay? But before that, let me write tan 2a formula also. Replace, okay, we will move on to third formula later. Now, let me rearrange this. Let me rearrange this. How do we rearrange? Just a moment. See this. Cos 2a is equal to 1 minus 2 sine square a. And let me write 2 sine square a. Let me bring this 2 sine square a to LHS and cos 2a to RHS. And thereby, what is the most important formula you will be getting? The rearrangement of the formula, what you get is 1 minus cos 2a is equal to 2 sine square. Similarly, if you see this one, bring this 1 to other side, then you will get 1 plus cos 2a is equal to 2 cos square. This is the most important thing to be understood. Why most important? I'll explain you that. The reason also, I'll explain you. How is it used in calculus also? I'll explain you that. Now, if you divide, know what happens? 1 minus cos 2a whole divided by 1 plus cos 2a is equal to 2 getting cancelled, you'll get tan square. So the important part of this cos 2a is that if you know only cos 2a, then you can find out sine a, cos a, and tan a. That means only cos 2a gives you the values of sine a, cos a, and tan a. One more important thing, how we make use of this in calculus. Sometimes in calculus, you will have to reduce the powers. Sometimes in calculus, you have to reduce the powers. What is the meaning of reducing the power? Here, the power is 2. You see that? What is the power here? 2. What is the power here? 2. What is the power here? 2. And if you want to reduce the power 2 to 1, what is the power here? 1. What is the power here? 1. Here, 1. Here, 1. So the power is reduced to 1. These are called reduction formulae. Further, you will be knowing that. Reduction. What is that reduction happening there? The power is getting reduced. That is the reason why there is more and more prominence for cos 2a formula. The reason is only cos 2a gives you all the remaining trigonometric ratios, sine a, cos a, and tan a. Obviously, they're reciprocals. Maurya, This is very important. Whenever you come across 1 minus cos 2a, immediately you have to say 2 sine square a. Whenever you come across 1 plus cos 2a, immediately you have to say 2 cos square a. Whenever you divide one with other, 1 minus cos 2a by 1 plus cos 2a, then division of these two obviously gives you tan square a. That is a prominence of cos 2a. Now, how is it used? How is it used? Let me show you that. See, if you want sine A, then simply sine A is got by plus or minus root over 1 minus cos 2a by 2. Similarly, if you want cos A, can be written as plus or minus root over 1 plus cos 2a divided by 2. If you want tan A, do you respond, please? Any one of you?
1 minus cos 2a divided by 1 plus cos 2a. I mean, 2 into 1 minus cos 2a. So 2 should be there, right? Oh,
No,
sorry.
2 gets cancelled.
Cancel. All right, sir.
2 gets cancelled. So, why plus or minus we must write? Plus or minus is to be written. Why we have written this? Sometimes it becomes plus, sometimes it becomes minus. We know allied angles. Sine is positive in the first and second quadrants. If A is lying in first and second quadrants, we take plus. If A is lying in the third and fourth quadrants, we take minus. Similarly, cos A becomes positive in first and fourth quadrants, rest of the quadrants negative. Tan A becomes positive in first and third quadrants, rest of the quadrants negative. That's the reason why, according to the presence of the angle, or according to the size of the angle, or according to the angle in which the angle in which the quadrant in which angle is lying, according to that we write the sign. So this is also very important to be understood. So why the prominence? Only cos 2a gives you all the sine A, cos A, and tan A. So you can have a question also on that one. Okay, that's okay. Now coming to third one. It is very simple. Third one, the formula, is tan of A plus B. Tan A plus tan B upon 1 minus tan A tan B. Replace B with minus A. Replace B with minus A, replace B with A. Replace B with A, then you'll get third formula. Replace the same process, B with A. Then what happens? Tan of A plus A you'll get. What is tan of A plus A? Tan 2A will become tan A plus tan A divided by 1 minus tan A into tan A. So 2 tan A divided by 1 minus tan square A. Are you there, both of you?
Yes, sir.
Yes, sir.
So this is tan 2a formula. This is the third formula. So in what way we can extend them, or we can transform them to submultiples? Very simple. I'll explain you just how is it done, so that you need not have to by heart anything. Like what? Now, Maurya, you tell me what is sine 2a, please?
Sir?
What is sine 2a? I wrote that.
Oh, wait, sir, it's not showing me anything.
Sine 2a formula.
No, sir, it's not on the screen.
Not on the screen, but I wrote it, no?
No, but before, sir.
No, we have, I'll show you the list of the formula so that you will see that. In the list of the formula, what is sine 2a there? Just see that?
No, sir. There's nothing showing on the screen. It's just stuck as previous.
Check it out now.
Yes, sir. Yes, sir.
Yeah. Sine 2a formula I asked you. Sine 2a is 2 sine a cos a.
Oh, all right, sir.
There.
Yes, sir. Yes, sir.
What I'm saying, if you take sine 2a as 2 sine a cos a, then I want to convert this. This is a multiple, please. This is a multiple. I want to convert it to submultiple. Submultiple means what? Replace 2a with a. Replace 2a with a. Then replace a with a by 2. That's it. 2 sine a by 2 cos a by 2. So multiple itself gives you submultiple. Multiple itself gives you submultiple. Another way also I'll tell you. Sine a can be written as sine of 2 into a by 2. Correct? Now, what happens here? If you see this one formula, replace a with a by 2, that's it. Replace a with a by 2. Come on, tell me the formula then.
Replace a with a by 2, then it will be sine 2a
That's
by
it.
4.
That's what it is. 2 sine a by 2 cos. I wrote this, but I'm showing you another way. What is that I said?
Alright, sir.
2a replaced with a, and thereby a must be replaced with a by 2. A must be replaced with a by 2. Okay. So sine, if you know multiples, take it as granted that you know submultiples. That's what I'm saying. If you know multiples, take it as granted that you know submultiples. Simply replace 2a with a and a with a by 2. That's it. Okay. Now, similarly, do you tell me cos2a formula? Paurya?
Yes, sir. Cos square x minus cos square a minus sine square.
That is cos2a you're talking about. What I'm talking about is
Sir, you asked cos 2 only, right?
cos a. How it can be written?
Cos a. So we're taking 2a. A is equal to a by 2a. So cos square a by 2 minus sine square of a by 2.
Next formula?
That's tan a. That is 2 tan a by 2.
No. The same formula, cos a.
Conversion.
Yeah.
Conversion. So which one I'll do, sir? Sine or cos first?
Both. Whatever.
Okay, so 1 minus 2 sine square
A by 2.
sine square a by 2.
Yeah.
And then the other one will be cos 2 cos square a by 2 minus 1.
And then next one?
That's tan. So tan, I don't remember properly.
Yeah, just see that, no problem. You'll be remembering slowly. When you are applying, no? When you are applying, till you get it by hearted or noted, you used to write the formula in the problems. While solving the problems, you have to make a note of it. So this is called
Sure,
submultiples. So when you know multiples, take it as granted, submultiples also there. Also can be derived from the multiples. Okay. Similarly, do you tell me what should be tan a bhavita? Tan a in
2
terms.
tan a by 2. 2 tan a by 2 by 1 minus tan square a by 2.
So these are submultiples. Similarly, this can also be converted. Like what? A by 2 if you have now, that becomes A. A by 2 if you have now, this becomes A. If you have A by 2 here, this obviously becomes 1 minus cos 2a upon 1 plus cos 2a. This is what I like to tell you. This is nothing but the multiple and submultiple angles. Is it clear, Maurya, up to this?
Yes, sir. Yes, sir.
Yeah. Now we will move on to 3a. How 3a? Sine of a plus b formula, sine a cos b plus cos a sine b. Bhavita?
Replace B with 2A.
That's it. Have you gone through the document sent by me? So replace b with 2a. Then sine of a plus a becomes sine 3a. Then sine a into cos, replace b with 2a, Maurya. Sine a cos 2a plus cos a sine 2a.
2a.
Bhavita, do you help me out now in simplifying this?
Sir.
I
Yes,
want
sir.
to get this totally in terms of sine, because sine 3a formula. Do you help me out in simplifying this formula? Do you know sine 3a formula, Bhavita?
3 sin A minus 4 sin cube A.
That's what. You know that. Then what I'm asking you, just do help me out in simplifying this to that form, because you said the formula, that's okay.
Yes, sir.
Sine A. Now tell me cos 2a in terms of sine, Maurya.
Sine, that's 1 minus 2 sine square A.
Similarly, sine 2a formula.
Sine 2a, that's 2 cos square A plus minus 1.
No, repeat. Sine 2a.
2 cos square A. Oh, wait, sine square is sine square. Sine square is sine square.
I'm talking about sine 2a here.
Yes, sir, yes, sir.
Now expand it. Sine A
That's
minus
sine A minus 2 sine cube A
and
plus
keep this 2 sine as it is, cos a into cos a cos square a. How cos square a can be written? 1 minus sine square a.
yes, sir.
Cos a into cos a cos square a, 1 minus sine square a. Just check it out. Expand it. 2 sine a, 3 sine a. Minus 2 sine cube a, minus 2 sine cube a, which gives you minus 4 sine cube a. So this is sine 3a formula. Just said that. Just now you might have heard that, Maurya.
Yes, sir.
They are given all these formulae from their ninth class itself.
9.
That is the education system in here. They might not be knowing the proof, but they know the formula by hearting. Happens here. That is where she's telling the formula instantaneously, you know, and she's good. That's why I'm happy. Sine 3a is derived like this, Bhavita.
Yes, sir.
And do you know the reduction formula related to this, Bhavita? Reduction formula means, just now I said, what is the reduction formula for this? Let me write that first. Sine 3a is what? 3 sine a minus 4 sine cubed. Do you tell me that? Reduction formula means reducing the power 3 to power 1. It happens in integration further in your 12th class. You'll be getting that. Integration. You cannot integrate some functions directly with higher powers. That is the reason why you will have to reduce the power. You'll have to reduce the power. Then how it happens? Just check it out. 4 sine cube a is equal to 3 sine a minus sine 3a. Check it out. What is the power on left hand side, please? What is the power on left hand side? I repeat the question. 3. What is the power on right hand side? 1. What is the power here? 1. This is called reduction. Bhavita.
Sir. Yeah, sir.
Do you know this reduction? If you don't know, you say no. If you know, yes, just a hand.
No, sir.
Okay, no issues. No issues. How it is used further, that's what I'm saying. How it is used further, you know. Further, you will have a topic by name integration. Did you hear the name integration, Bhavita?
Yes, sir.
When? In which class?
Like in like in 10th class, we did differentiation and integration, but I don't exactly remember the topic.
Good. So you will have to integrate this further. This is a symbol of integration. Maurya, this is called symbol of
Sir.
integration. Integration is nothing but summation. The alphabet S is taken and in the elongated form it is denoted as integral symbol. So there is relation between S and integral symbol. Bhavita, do you hear me? Integration,
Yes, sir.
practically the application of integration is summation. What is the first letter of summation? S. S in the elongated form is shown as the symbol of integration. Okay, that means you have to understand that we add them. That is, we sum all the points, finding the areas, finding the volumes, and all this. You'll be getting this in all your further studies in your engineering and further. You will have this integration not only in your engineering but in physics and chemistry also. Further,
Yes, sir. I think we have a differentiation.
yeah, you have differentiation, you have integration. Without this, in physics, some physics concepts cannot be solved. Okay. So what happens now? This integral sine cube x, you cannot integrate directly. Then you must remember this. You have to reduce the power. So what we do, we write it as 3 sine x minus sine 3x whole divided by 4. Now, according to the principles of integration, when the higher powers cannot be integrated, now you can integrate if the power is 1 like this. If the power is 1 like this. This is the reason why I just said it as reduction. But no one, while teaching trigonometry, say this, teach this. And that is the reason why students think that that is a different formula and that is a different application. Not at all. Not at all. This is very much related to trigonometry only. So this will be applied in your 12th class. Understand that. So sine 3a, not only remembering the formula, Bhavita, you have to remember the reduction also. 4 sine cube a is equal to 3 sine a minus sine 3a. Whenever you come across 4 sine cube a, you can write it as 3 sine a minus sine 3a. That is the reason why in the formula list also I mentioned that clearly. Let me show you that so that you will have more clarity about that. Just see that. See here in the box for formula number 23, please. Formula number 23, just read that, Maurya.
Sine 3a is equal to 3 sine a minus 4 sine cube a. Should I read the box, sir?
Yeah.
That is also sine cube a is equal to 1 by 4 into 3 sine a minus sine 3a.
That's good. Similarly, cos 3a can also be derived. How cos 3a can be derived? You can say now, cos of a plus b is there, no formula. Maurya, tell me cos of a plus b. You're not saying I'm writing, Maurya. Maurya? Are you there, Maurya? Yeah, Babita, are you there?
Yes, sir.
Come on, tell me now.
A plus 2a.
Come on. Come on, read that. minus sine A into sine 2A. Come on, now help me out
Sine.
in writing this formula totally in terms of cos. Maurya?
Cos A into 2 square A minus 1.
Yes. Come on, tell me next step.
2 cos cube A.
Hmm. 2 cos A is there. Instead of sine square A, we write 1 minus cos square A.
4 cos cube A minus 3 cos A.
Yeah, Maurya. Now do you hear me?
Yes, sir, yes, sir. My parents are on a call, so they're on a WhatsApp call, so they were using the network. So my
Cos
network.
3A is equal to 4 cos cube A minus 3 cos. In the similar manner, I derived it, Maurya. This is simple. You can understand that easily. Like replaced B with 2A and we derived it. And now tell me, Bhavita, do you tell me the reduction formula related to cos 3A now?
Yes, sir.
Come on, tell me.
4 cos cube A equals to
That's it.
cos 3A plus 3 cos A.
You understand that, no?
Yes,
Maurya,
sir.
do you understand this? So
Yes, sir, yes, sir.
you have to remember these formulae, sine 3A, cos 3A. And similarly, you can derive tan 3A also from tan of A plus B. What is tan of A plus B? As you know, it is tan A plus tan B upon 1 minus tan A tan B. Now replace B with what, Maurya?
To find 3A, replace B with 2A.
Yeah, B to be replaced with 2A. Come on, read it out now. What happens? I'm writing directly tan of A plus 2A, which becomes tan 3A.
Tan 3A.
And now what happens to this? Tan A plus.
Tan A plus tan 2B.
Tan
2A.
2A. Come on, tell me tan 2A formula. Just now we derived it. 2 tan A. I'm writing the formula again. I'm tan 2A formula. We have already learned it is 2 tan A upon 1 minus tan square A whole divided by 1 minus, come on, tell me, tan A into
So,
2 tan A upon 1 minus tan square. I hope you understand what I'm writing, Maurya.
no, sir, this part I didn't get it properly, sir.
Yeah. You replaced B with 2A, no?
Yes, sir.
Then you will get tan 2A here.
Yes, sir.
What is the formula we derived for tan 2A? Just now I explained.
2 tan A by 1 minus tan square. That one.
That's it.
Okay. Okay. So it's whole divided by 1 minus tan A into.
Again, tan
2.
2A you will get, no?
Yes, sir. Yes, sir.
Yeah. I have to write that totally. Bhavita.
Yes, sir.
Yeah, you are not objected here. I have to write the entire division, no?
Yeah, like you have to do LCM in the next step.
No, not that. I did not write whole divided by there. Tan A plus. That's it. Now, final formula I'm writing directly. You have to take LCM here and you have to simplify Maurya. This becomes
Right, sir.
3 tan A. Just open the formula sheet I gave you. Minus tan
Okay,
cube
sir.
A upon 1 minus 3 tan square A. This is the final formula. Okay. So, we have seen sine 3a, cos 3a, and tan 3a. Okay? All the formulas we have finished. Even similarly, you can even have the formula for cot 3a also by using cot 2a for cot of a plus b formula by using cot of a plus b formula. Okay? Is the screen is clear, Bhavita?
Yes, sir.
Yeah, I removed it, Maurya.
Yes, sir.
Is it okay? Should I move to the
Yes,
next?
all right, sir. Sure, sir.
Yeah. Check it out. Now, this is what we have derived for multiple and submultiple angles. Multiple means 2a, 3a, 4a, or nothing but multiples. And submultiples are, here this is wrong. This is not 2. 2 is not there. Tan A is 2 tan A whatever 1 minus tan square. This is submultiple. Sine 3a multiples, cos 3a multiples, tan 3a multiples. You can even derive cot 3a also. But when you know tan 3a, you need not have to remember cot 3a. Even if you remember, that will be good. Okay. Now after that, for the objective purposes, you will have to remember these results. For objective purposes, you will have to remember these results. What are they? A plus b is equal to pi by 2, then sine square a plus sine square b is equal to 1. This I will be discussing further for the objective purposes. Objective questions you will have to answer with less time. Then in that case, we will be making use of it. Not only this, for the higher level, that is IIT advanced level, you have some more such formulae. That is, these are through graph, you have to remember this. That is cos theta plus sine theta, cos theta minus sine theta. When is it positive? When is it negative? And all this I'll be explaining you through derivation. Do you know this part, Bhavita?
Not exactly, sir.
Did you ever learn this?
Like I didn't learn in which quadrant it will be positive and negative. I just know how to find out cos and sine from the identities. Like if they give cosecant theta plus cot theta equals to this value.
No, that's different thing. That's a different thing. This is for the advanced
Yeah.
level. We will be applying this. Anyway, we will see that at the end of all the questions, because you will have to know the basic problems, and after that we'll be doing that. Okay. Now, did you finish your Telugu Academy textbook, that is exercise, third exercise, multiple and submultiple angles exercise, Bhavita?
I started, sir. I didn't finish it yet.
Yeah, you started it.
Yeah, sir.
Okay. So, let me work out the problems in the NCERT textbook. And you must be knowing, Bhavita, whatever IIT JEE examination is there, the entire syllabus is based on the national level syllabus. It is CBSE syllabus. Do you know that or not?
I know that, sir.
Yeah, that's the reason why. And he's in a CBSE pattern, and I'll be making you do like this further what we do now. I'll be giving you the entire theory of the related topic, and I'll be asking you to, based on that theory, I'll be asking you to work out the problems that are present in the board textbook. For Maurya, it is CBSE textbook. For you, it is your state board textbook. Do you understand what I'm saying? So,
Yeah,
after you finish that part, in parallel with that one, I'll be working out the objectives, and you will have to finish up the board problems. And whatever the doubts you have in the board level questions, I'll be discussing in between. So, in parallel with my objective discussion, You will have to finish your board on your own. Maurya, you will be trying like that.
Right.
I think you understand what I'm saying.
Yes, sir. Yes, sir.
We finished this exercise, Maurya, and I think where we stopped, just check it out.
So I think we have to start with number 7.
Yeah, Bhavita, you'll also be working along with me. Just check it out. The question, do you see the question on the screen, Bhavita?
Yes, sir.
This is NCERT textbook. Come on, tell me now, what is the 7th question here? Tan of pi by 4 plus x. Whole divided by tan of pi by 4 minus x. Yeah, tell me now, Maurya, tan of a plus b formula, please.
Oh, sorry. Tan of A plus B is equal to tan A plus tan B divided by 1 minus tan A tan B.
Can I write like this? If you say okay, I'll write that. Tan A means tan pi by 4.
Yes, sir.
What is tan pi by 4?
Tan pi by 4 is 1.
That's
45 degrees. That's 1.
1 plus tan x divided by 1 minus tan pi by 4 tan x. That is tan pi by 4 is 1 into tan x. So you'll get like this. If you do not understand, ask me. I'll explain it again. If you understand the numerator, you can say denominator comfortably. Come on, tell me what is the denominator now.
That's tan. Sir, first let's say the formula. Is it fine with you?
Yeah, that's good.
Tan of A minus B is equal to tan A minus tan B divided by 1 plus tan A tan B.
Come on, tell me now.
So in this case, tan pi by 4 tan minus tan minus tan x.
Tan pi by 4 means 1.
So pi by 4 is 1, so neglected.
Yeah, not neglected. You have to write 1 minus tan x.
Okay, fine. Divided by 1 plus tan
Pi by 4?
1 plus tan pi by 4, that's 1 into tan x.
Yeah, it takes little time, but you have to practice it more.
Sure, sir.
Without practicing, because trigonometry is no way can be solved without the formula. So now if you
Yes,
find the
sir.
reciprocal of it, just to check it out, 1 plus tan x, that becomes 1 plus tan x whole square. Divided by 1 minus tan x whole square. Okay? It's proved.
Yes, sir.
Now, let us come to 8th problem. Come on. 8th problem we are working out now. I think I need not to explain you that, Bhavita, 7th one.
Yes, sir.
8th one. Cos of pi plus x into cos of minus x whole divided by sine of pi minus x into cos of pi by 2 plus x. Now, come on, tell me what is cos of 180 plus theta, Maurya? Which quadrant first?
So 180 plus theta.
Huh.
So that's third quadrant.
Yes.
So I was muted a while back. So,
Yeah. Then what is the value?
that's minus 1.
Minus cos.
1 into
What is cos of minus theta?
cos theta.
Whole divided by. Kavita, sine of 180 minus theta, denominator please.
Sin x.
And cos of pi by 2 plus x.
Minus sin x.
This minus getting cancelled. Okay. What is the final answer? Cos square
Cot
x
square x.
divided by
Sine square x.
what is its value?
Cot square x.
That's it. Okay. That's it, please. Hope you understand that, Maurya.
Yes, sir.
Now let us finish up this. Come on. You tell me first. Cos of 270 plus x.
Plus x. Fourth quadrant.
Yeah.
So over there, cos is positive.
Yeah.
And 2 pi, that's 180 plus, oh, sorry. So that
270.
told, right? 3 pi by.
270.
No, say, other one, sir. After this one.
No. You tell me, first of all, it's
This
value,
one,
no?
this one is in
Fourth quadrant.
fourth quadrant. Yes.
Fourth quadrant, cos is positive. You said,
Positive.
right? But for
Yes.
3 pi by 2, will it change or will not change? For
3 pi by 270, it'll change.
Yes.
Right?
Yes.
It'll change.
Yeah.
For 90 and 270.
Come on, tell me that.
Sine.
Correct. Now coming to the next one. Cos of 2 pi plus x.
That's 3/6. That's first quadrant again.
Yeah. Then
So it won't change, sir.
cos x. Come on, tell me this one. Cot of 270
That's second quadrant.
No, see properly.
So 270 minus 6. Third.
Cot is positive.
Yes.
For 270.
Yes.
For 270, it changes.
Cot is positive.
For 270,
Yeah, it's
changes.
positive, but it changes.
Then cot becomes
Tan.
plus cot of 2 pi plus x.
2 pi. That's first quadrant again. It doesn't change and it's negative. No. Yeah, positive. Sine and cos are both positive in the first quadrant.
So now sin x into cos x. Tell me tan in terms of sin and cos, please.
Tan is 1 by sine by cos. Sine by cos plus cos by sine.
Come on, tell me LCM there.
LCM, that's sine square x plus cos square x divided by cos x sine x. Sine x cos x. So on top it will be 1 divided by sine x into cos x.
That's it.
We can cancel them off.
We can cancel it. What is that remaining?
Sine square x plus cos square x,
1.
which is 1.
It is RHS. Proof. Okay. So that's it. I hope you understand that.
Yes, sir.
Yeah.